Okay. So I guess more participants are joining, but as per the schedule, we will start our webinar as and we will keep on admitting the participants those are actually joining. So hope um, as per the registration, we are expecting almost up to 100 participants to participate in this webinar. So ladies and gentlemen, warm welcome to all of you to this highly anticipated webinar on electric vehicle testing, certification and validation, key trends and developments in the EV test equipment industry. We are truly delighted to have such a diverse and distinguished audience uh, gathered here today. In this dynamic era of sustainable mobility, the electric vehicle sector is experiencing unprecedented growth and innovation. As we transition towards the green future, the significance of robust testing, precise certification, and thorough validation process cannot be overstated. Our webinar aims to shed light on the pivotal trends and advancements within the EV test equipment industry that are shaping the way we ensure the safety, performance, and reliability of electric vehicles. Throughout the course of this event, we have the privilege of hosting esteemed experts and thought leaders who will provide insights into the latest development, challenges, and opportunities in this ever-evolving landscape. From cutting-edge testing methodologies to emerging regulations and market demands, we are here to explore the forefront of technological progress. I encourage all of you to actively engage, ask questions, and share your perspective during the discussion. Let this platform be a collaborative space where knowledge flows freely and ideas spark innovation. Once again, I extend my heartfelt welcome to each and every one of you. Thank you for joining us in this journey to uncover the future of electric vehicle testing, certification, and validation. So before we actually begin our exploration together, I extend our sincerest gratitude to ISIS Technology Private Limited and Gantner Instruments for their invaluable support as sponsor of our webinar on electric vehicle testing, certification, and validation. Your commitment to fostering knowledge sharing and innovation in the electric vehicle industry is truly commendable, and we are honored to have you on board. We would also like to express our heartfelt appreciation to our supporting associations, Indian Energy Storage Alliance, India Electric Mobility Council, Smart Energy Council Australia, and the Electric Mobility Financiers Association of India. Your collaborative spirit and dedication to driving sustainable mobility solutions have greatly enriched the scope and impact of our webinar. Together, with your unwavering support, we are able to provide a platform for experts, enthusiasts, and stakeholders to explore the critical trends and developments in the EV test equipment industry. Your contributions have been instrumental in making this event a resounding success. Thank you once again for being integral to our journey towards a green and more sustainable future. Before we start, actually, I would like to introduce to our first speaker, that is Mr. Gurcharan Dhillon. He is the Director, E-Mobility from Customized Energy Solutions. A brief introduction to Mr. Gurcharan. Gurcharan has 30 plus years of experience in areas of strategy, business, planning, operations, sales, marketing, and product planning in Asia and Middle East. He has worked with leading Japanese and Korean automotive OEMs like Toyota, Nissan, Honda, and Hyundai. At Customized Energy Services, He leads e-mobility practices for various technical and commercial aspects related to e-mobility, focuses on megatrends, connected autonomous shared and electric mobility with focus on powertrain, e-components, vehicle integration, battery charging, battery swapping, and emerging technologies. He has graduated in mechanical engineering and has an MBA in sales and marketing. Today, he is going to start the discussion by giving us all an overview of the EV test equipment, EV testing certification and validation industry. Over to you, Mr. Gurucharan, and welcome to this webinar.
Thank you. Thank you very much, Santosh ji. We truly value our association with Smart Energy Magazine and are privileged to be part of this very informative webinar. My greetings to the fellow panelists and good afternoon to all. Am I audible? Because I've seen at the chat window, there's some comments related to the voice quality. Am I clearly audible?
Yes, sir, you are clearly audible to us.
Okay, so I'll just get the presentation up.
Yeah. So I guess I have made you a co-host, so you can
Yes.
also start sharing the screen and presenting. Yeah.
Yes. So is my screen visible?
Currently, it's not visible, sir.
Okay, so I just figure out what I'm doing wrong.
Now just try it.
Okay, now is it visible?
Yeah.
Okay, fantastic. Okay, so good afternoon, everyone. Again, my name is Gurucharan Dhillon, and I'm here to just walk you through about an introduction into electric vehicle testing, certification, validation, and I think details regarding modalities of testing and the services, etc., will be shared by my co-panelists on this panel. You can see at the window behind me, it's a very beautiful afternoon in Pune, where I am, and I hope the weather is treating all of you kindly wherever you are in India. So before going into the subject matter, I'd just like to start with a very quick introduction of what we do. We are basically a consulting company. We work alongside our clients, and we have very strong understanding in the area of trends, markets, technology, and sustainability. This is our location map. Our focus regions, in addition to our headquarters in the US, is India, which is where I am. We have offices in Asia, in Vietnam and Japan, an office in Dubai, and an office opening in Amsterdam in sometime next month. These are our main business lines in terms of emerging technologies. We look at batteries, charging, swapping, mobility components, stationary energy storage, product development, hydrogen, and microgrids. And these are just some quick highlights. We have worked with over 1,800 clients to date. We have 200 members in an alliance that we run, 60 plus of which are mobility companies. We've co-worked with 10 plus EV startups. There are 10 plus battery swapping companies who are actively engaged with us. 4 out of the top 5 battery companies in India are engaged with us. We also have a learning portal where we provide learning and training solutions to companies like Maruti Suzuki, Power Grid, and NTPC. Now I'll get into the subject very quickly. When we talk about electric vehicles or e-mobility in particular.
Gurucharan, sorry to interrupt you, but your slides are not getting changed, at least to me.
Oh my God. So what are you seeing on the screen, sir? Because I am
This is the first page only, that customize energy solutions and your name.
Okay.
Even for me, I think it's for everyone. You can see the chat.
Okay, so do I need to share again? Can I give this another go? Is it visible now?
No.
Okay, I'm just going back and trying and restarting the share screen mode. Okay, can you see what's on the screen now? There's a major component slide.
Yeah, now it's visible.
Okay, so I'll just, for the sake of check, I'll just go back one slide and just please let me know if it's visible. Uh,
Yeah, it's visible.
Yeah,
okay, so the change is now visible.
yeah, it's now visible.
Okay, fantastic. So I'll very quickly walk you through the parts you missed. Now can you see the world map? Hello?
Yes, we
Yeah,
can see that.
Oh, okay. So we're good to go. Okay. So like I said, this is our global presence. This is our, the technology lines that we are in. These are our client engagements. Now, when we talk about EVs, people normally talk about 9 very specific parts. I mean, most of them talk about battery and motor, but an EV is more than battery and motor. The battery refers to the battery pack, which is basically the power source for the vehicle. The inverter is what is converting the DC to AC to drive the motor. The controller is what is actually regulating how much power gets into the motor. Then of course you have the motor itself, which is the
Gurcharan, sorry again to interrupt you. I can only able to see the key highlights slide. I don't know what about others.
Oh my God.
Yeah, sir, what I will do is I have your presentation.
Okay.
So let me share the screen and I will, along with you, I will change the slide. So give just one minute for me.
Yes.
Yeah? Okay, if that is fine with you. Yeah.
Yes, please.
Yeah. Okay, fine. Visible to all.
Yes, visible. Yes, sir.
Okay. So, Guru Shivan sir, we can go. You can start your presentation. I will move according to you.
Okay. So please, if you can move to slide 7, then I can continue from there.
Next one.
The next one, sir. Next one. Next. Okay, fantastic. So this is visible to everyone, right? Okay, so the battery pack, we spoke about battery pack, we spoke about power inverter, we spoke about controller, then we were on traction motors. Then you have the charger itself, which is basically the onboard charger, which is both supplying current as well as recharging. And then you have the transmission, which is basically regulating the power that goes into the system. And can we move to the next slide, the DC converter? Okay, fantastic. Then you have the DC converter, which is basically converting DC current from the high voltage battery pack to low voltage, which is required by the system. Thermal cooling is extremely important because you need to maintain optimum operating temperature within the system. And then the auxiliary battery, which supports the low voltage components of the system. Can we go to the next slide, please? Is the slide transitioning or can we? Okay, so now this is basically an electric vehicle architecture. So it is most of those 9 parts put together, and it speaks a lot about how the flow of current and everything is going in. And this is from where I'm going to take the talk into the complexities of the system and where testing, validation, and everything comes into being. So one of the words that you will notice here on the slide in various places is a word called CAN. And there's another word that a CAN communicates to, which is an ECU. So I'll just take you to a quick introduction of what these words mean. Can we change the slide again, sir? Move to the next one, please. Okay. No. Next one, sir. Okay. So basically, for those of you who are familiar with the word CAN and those who are not, CAN basically refers to something called a controller area network. So when you think about a human body, if you look at the nervous system of the body, it basically ensures that all the stimulus, so you feel a touch on your leg, but your brain sends a signal to your mind. That's what the CAN system does. All the ECUs in the car are in the vehicle, whether it's a scooter or it's a car or a three-wheeler, they're all interconnected through this CAN protocol. This CAN protocol basically is communicating through various ECUs. Now, when it comes to ECU, what are they controlling? These are basically electronic control units. They can control the functioning of the engine, steering, power windows, airbags, audio systems, security, access, almost everything that's going on in a vehicle. And as we move forward, I'll share some more detail on the power electronics. Can we move to the next slide, please, sir? High voltage system validation. Okay. Now, like I was explaining, you have a main battery pack and you have an auxiliary battery. So there are two voltage channels that are working in any electrical system. There's a high voltage system and there's a low voltage system, which is 12 volt, which is fairly easy to manage. But the high voltage system that is highlighted here in red, this requires very high requirements for sampling rate, which is when you're developing these products, you need to test them with very, very careful validation and test data. And some of my co-panelists will be sharing some data on this. Another big challenge in the testing and the validation of the system is that all these measurements need to be synchronized in time because they're all giving very different inputs to the overall system. You need to aggregate all of them and see how they're balancing or impacting each other. And it also has to ensure that all data is recorded because there are numerous data points that are created every millisecond. And research says that in the cars of the future, the day won't be far when every car will be generating a few terabytes of data over its life cycle. So data management also has a very big role that has to play. Can we move to the next slide, sir? Okay. Now, whenever we speak about cars, people keep referring to 4 words. Someone says case, somebody says connected, autonomous, somebody talks about shared. But basically, what is connected car architecture? When you look at it from a hardware perspective, connected car architecture basically refers to 2 aspects. The first is when you have an embedded system, which is something that is part of the vehicle. So things like internet connectivity through an in-vehicle SIM card, GPS navigation, entertainment, diagnostic, all these are typically vehicle embedded systems. And they also communicate with external inputs like state of traffic, route avoidance, etc. And then you have the tethered systems. Tethered systems are basically when you are logging on to your network through an external medium like a smartphone, a tablet, or any other connected media through a USB or Bluetooth, and you're basically using it to either access your entertainment, access road information, or also your vehicle diagnostic system in terms of connected cars. So when we look at the applications, key applications of connected cars, can we move to the next, please, sir? Yes, sir. So if you look at the key applications of connected car, the use cases, some of them are used for e-commerce. So you're all familiar with your FASTags that are now mandatory in cars. So all toll payments, etc., are happening through this. You can also use it for shopping, etc. Entertainment and music streaming is what we heard about in the third part, remote diagnostics, maintenance alerts, and vehicle notifications in terms of requiring periodic maintenance is also kept available through this facility. You can understand where the traffic is. Autonomous cars are now, level 1 and level 2 autonomous cars are now equipped with technology that guides the driver when he's departing from a lane, or it supports him in terms of adaptive cruise control. Also can give a signal for emergency braking if the driver response is not fast enough. And also well-being sensors which monitor the air quality in the cabin, your state of awareness, your sensitivity to the steering, and others. Can we move to the next slide, sir? Now, the great thing that, all these things are happening in the vehicle, but what is actually making these things happen? So there's a very complex web of electronics, ECUs, and communication protocol that's working behind an automobile. And very famously, people have said that automobiles are no more about vehicle engineering. They're about electronics. They're about instrumentation. They're about, they're about technology. It's almost like technology on wheels. So if you can see in terms of the electronic integration that is available in a vehicle, it goes across all systems of a vehicle, starting from braking, steering, engine, safety, lighting, electronics, navigation. So there is no part of the vehicle that is not supported by this electronic architecture. Can we go to the next slide, sir? So now I'd like to briefly talk about, sorry, sir, we went one slide ahead. Can we go back, please? Okay. No, you can keep that slide. Okay. So basically, in terms of product development, earlier product development was very physical and human interface developed. But today, the cars of the future, they're developed with something called digital twin technology. And digital twin interfaces across three aspects. The first is product, the second is production, and the third is performance. In product area, it helps you in efficiently designing new products by analyzing product performance under a lot of simulated scenarios. The next is production, where it helps you validate your manufacturing process and maximizes efficiency. And the third is performance, where you actually capture and analyze operational data when a unit is in operation to understand what are the data points that you need to work on and improve performance. Now, how this is done is through a very complex software development environment, which goes across totally 5 stages. The first 3 are software validation itself. The next 2 are system and software validation. It's called model in loop, software in loop, processor in loop, hardware and vehicle in loop. So these are basically stages of evaluation of the software where you are testing all the functions that we saw in the vehicle electronic system and seeing that how well they are communicating and talking to each other. Can we go to the next slide, sir? Okay. Now, with so many electronic gadgets talking to each other across a vehicle, I don't know how many of you have memories of old family radios which used to have a kind of a tether or something, a disruption noise when there was some other frequency that it was engaging with. Now, think of the number of sensors that are actually available on a vehicle and think of how much they are communicating to each other in terms of generating radio frequencies and frequency ranges. So you need to make sure that none of these frequencies interface with each other, they don't interrupt with each other, and they're also allowing each other to function efficiently. So almost every part in a car, which is, let's say, audio system, the engine, the security system, everything needs to be connected to be tested, how their electromagnetic fields are interacting, and whether they're actually creating any EMI, which could be disruptive to the other vehicles in the range. So, to talk more about these aspects of testing. So we spoke about parts of how frequently data needs to be gathered, the need to know in a development environment, how fast, to understand in a data environment that how actually software and the unit side is integrating, to get data about unit testing, integration testing, and to understand how important and what are the various services that are offered to streamline and make this journey more seamless. We have my other co-panelists on board, and I'd just like to end with one saying from Elon Musk. That actually just brings, I was just setting the context, so this brings me to the end. Elon Musk very famously says that he encourages other manufacturers to bring electric vehicles to the market because he believes that the market needs a lot of iteration, it needs a lot of improvement, and the only way that humanity can achieve a sustainable transport future is through e-mobility. So we are committed to the cause of e-mobility, and I'll be very happy to hear from the other co-panelists on what their thoughts about testing and the services that are offered in this area. So that's the end of my presentation. I'll be happy to take any questions if there are.
Okay. Thanks a lot, Guru Charanji, for this wonderful presentation and setting the tone for today's webinar. The floor is now open for any questions that are there from the participants. If there is any questions that is there, the participants can unmute them, and then they can tell their name and the organization they belong to, and they can ask the question.
How is it, Nariman?
Okay. There was Mr. Mayur. If you want to ask the question, then you can go ahead.
Sir, Sohit Pal this side. Sir, could you please let us know what is the life of this traction motor and power pack, and how impact in day-to-day life and maintenance point of view?
I'm sorry, I couldn't hear you very clearly. Your question is?
First, my question is what is the fundamental and what is the life of this traction motor?
Okay.
And second is how battery life is concluded by supplier, and how we ensure the life and backup of this battery power pack.
Okay. So you basically asked two questions. I'll try to answer both of them separately. So life of motors, I mean, there's been a lot of interest in life of battery because that is the most high value part in the vehicle. But I'll start with the motor, which is the easy part. So motor basically is not something that has been developed newly for this industry. In fact, something as simple as a ceiling fan is also using a motor. And motors typically have pretty long life. The only challenges can be when it has a very high voltage in the circuit, or the system is not able to cut off or something. But typically motor lives can range from 10 to 15 years. So that is not a very big concern. In terms of battery life, it's completely linked to the number of cycles that it has been designed for. So cycle basically refers to the number of times a battery unit is discharged and then again recharged. So in terms of design cycles, vehicles are normally designed for about 7 to 8 years life. That is a design consideration. And if you are in the market looking for an electric vehicle, the cycle life of the battery will be specified in the specification details that the manufacturer is offering you. So very simply, you will divide that by 365, and you will know how many years your battery is going to last.
Okay, sir. Thank you, sir.
Okay, so I guess we will move ahead, and Mr. Gurusharan is going to be there with us during this webinar. So as we proceed further, you guys, there will be more interaction that are going to happen, and if there is any query that is there to Mr. Gurusharan, you can definitely come back to him at a later stage of the webinar. So thanks a lot. Thank you very much, Gurusharan, for coming to this webinar and setting the stage for the webinar. Thanks a lot. Thank you very much, and giving us a wonderful presentation. So moving, so moving ahead, actually, the next speaker is Mr. Rajaram TR. He's the country head India at Gantner Instruments India Private Limited. Before I hand over the mic to him, I would like to give a brief introduction to him. So Mr. Rajaram TR currently heads the Indian operation of Gantner Instruments through its Indian subsidiary, Gantner Instruments India Private Limited. With 18 plus years of experience in providing test and measurement solutions for automotive, aerospace, transport, energy, and civil segments of the Indian industry, he has been extensively collaborating with EV manufacturers by providing high-speed data acquisition system for measurement of electrical, mechanical, and thermal parameters in testing of batteries, inverters, and electrical motors. A brief introduction to about Gantner Instruments. So Gantner Instruments specializes in precision measurement of mechanical, thermal, and electrical quantities. With its creative measurement solution, Gantner Instruments has developed since its foundation in '82 into a globally recognized player on the data acquisition system market. Gantner Instruments data acquisition systems are tailor-made for automotive testing applications, providing specialized equipment and tools for ensuring vehicle and component safety, reliability, and performance. Their products can effectively and accurately perform durability, road, climate, vibration, and endurance tests, providing valuable data for vehicle and component design and precision and performance improvement. They offer flexibility. They offer flexible, easy to use, and customizable data acquisition solutions to meet the specific testing needs of the customer. Gantner Instruments is headquartered in Strunz, Austria, with its Indian subsidiary located at Chennai, India since 2008. Today, he is going to share his views on the topic of Gantner Instruments high quality DAQ for EV testing. Over to you, Mr. Gurusharan. Over to you, Mr. Rajaram.
Yeah, thank you, Sandosh. Can you allow me to please share the screen?
Yeah, just give me 1 minute. Yeah.
Hello, good afternoon to everybody. So as Santosh told, my name is Rajaram, and I head the operations of Gantner Instruments here in India. So he had given a pretty big introduction about us, so I will not waste my time on this with the time constraint that we have. So we basically are a data acquisition, test and measurement company, specializes in providing high speed, high accuracy data acquisition systems as part of your EV testing ecosystem. So we provide data acquisition solutions that can measure electrical, mechanical, and thermal parameters. And when I say electrical, mechanical, and thermal, it covers the whole spectrum of signals or sensors that you are going to use as part of testing of your EV ecosystem. So coming to especially to EV, so we are present in automotive field for a long time. So our test and measurement equipments are used for conventional testing, that is IC engine testing also. But today I will focus mainly on EV. So what we cater to EV, as you can see in this slide, so you have three critical components of a EV, three basic critical components of EV, namely battery, inverter, and motor. And all these components requires extensive testing, and you need measurements at a very high speed, at a very high sampling. So Gartner Instruments provides this data acquisition hardware coupled with intuitive, very user-friendly software solutions for visualization and analysis of the data you get as part of this testing. So typical measurements on an EV testing, whether it may be on a battery, inverter, or motor, the typical parameters that you basically measure are basically high voltage and high current. Then you have low voltages, low currents. Then you have temperature, vibrations, strain gauges, speed, torque, power calculations, etc. So we have the data acquisition systems which can cater to all these channels of measurements which comes in as part of your testing of batteries, inverters, or motors. And all these systems are based with a resolution of 24-bit real-time sampling of 100 kilohertz per channel, and all the measurements what you take in are time-stamped real-time measurement, and it is completely synchronized. So when you speak about the typical testing applications that you see, basically when in an EV ecosystem, you have n number of tests that you conduct on your electric vehicle. So some of the major tests I have classified and put it here. It can be an electric motor dynamometer testing. It can be an electric vehicle chassis dynamometer testing. It can be a battery testing application. It can be a inverter testing application, or it can be something into hydrogen powertrain or alternate fuel kind of a testing. So these are particularly the basic kinds of test, or the main test that you do basically with your batteries, inverters, and your electrical motor. So what makes us special and successful in providing data acquisition solutions for the EV testing is, I have mentioned the 5 major USPs that we offer to the customer. So our systems are completely flexible. So it is easily scalable. It is easily expandable. We have various form factors of the hardware available, which you can pick and choose as per your test requirements, or based on the component that you are going to test. Again, we have an array of I/O modules available with us, which can take in almost all kinds of sensors. I think Mr. Senthil, can you mute yourself? Yeah, thank you. Again, very important factor to consider when you buy a data acquisition system, high speed, high accuracy, high resolution based data acquisition, is the term called galvanic isolation. So it is very important when you have a high accuracy, high speed data acquisition, especially in the EV environment where you are going to measure high voltages and high currents. You should always opt for a system which has got a very high galvanic isolation. And in Gartner, we provide all our Q series, X series, which is basically our specialized series for EV testing with a 1500 volt galvanic isolation, which is best in class. And this really helps in exact measurement of signals from your field, which you will see in the coming slides how we achieve it. We also now we commonly hear about batteries getting bursted, EV vehicles getting fired up. You had seen a lot of social media posts. You have also seen a lot of news articles on it. So high accuracy temperature measurement is also very important, and we provide cover input circuits in our DAQ modules such that you exactly measure temperature at the highest accuracy of 0.001 degrees Celsius, like that. Again, as my previous speaker, Mr. Gurucharan, told, when you test an EV, you have a lot of components that you under test, and you require different sampling rates. So there are certain parameters which you require at a real high speed, at real-time measurement, time-stamped measurement. And there are also other parameters like environmental parameters, which you don't measure at a very high speed. These are basically for monitoring parameters. So we have configurable data loggers available. So you can configure our controllers with different sampling speeds, different nodes. The IO modules can be connected to the different nodes of our controller, and each node can have a different sampling. So you can always group your high-speed measurements as well as your low-speed measurements using our flexible configurable data loggers. And at last, we Gartner Instruments believe in openness. So we are completely an open company. So we support almost all the well-known communication interfaces which is available in the market, starting with basic RS485 Modbus, Profibus, Profinet, CAN bus, DeviceNet, Ethernet, EtherCAT. So these are all the communication buses which are available in the market, and we support all of them. Our hardware can be linked to any third-party devices through any of these communication protocols, and we also support the multiple drivers for well-known softwares which are available in the market. So we are completely open. So this makes us one of the #1 suppliers when it comes to testing and validation requirements, data acquisition requirements in the automotive market. So as I told you, we completely believe in flexibility, scalability, and modularity of our products. So our data acquisition systems, we have made it such that different form factors of the hardware, data acquisition hardware is available to you. So you can have a DIN rail assembly, you can have a 19-inch 3U rack system, you can have a portable system for your onboard application. The internal electronics remains the same, but the multiple form factors are provided to the customers so that they can conveniently mix and match these series of products and use for the complete EV test process. Another 2 points which I would like to stress here is that we, again, Gartner, we believe that as a customer, you should be able to connect any kinds of sensor directly to our IO modules. So we have an array of IO modules, more than 30 to 40 kinds of array of IO modules available. Some are dedicated IO modules as well as universal IO modules, by which you can connect any kind of sensor directly to our modules. We don't expect the customer, you as a customer, to do basically any external amplification or signal conditioning of the sensors to connect to the DAQ system. So whatever is the kind of sensor you have, whether it may be voltage, current, thermocouple, IEP, cryogenic, strain gauges of different types. So whatever it is, you can connect directly to our IO modules. And we have got the 24-bit ADCs inbuilt into each of our IO modules, which can take care of the connectivity with the sensor. Again, since testing involves a lot of time as well as money, we have also brought about hot swappability into our entire product range. So by hot swappability, in layman terms, we simply mean that in case of any failure, you can just take out a module in running condition, take a new module from your stock, insert it into our backplane, and it starts running. There is no need for any configuration when you change a failure module. So maintenance becomes very easy with the complete hot swappability that we have brought about. Now I will touch about the importance of galvanic isolation. So when you are actually looking basically for high speed measurement, high accuracy measurement, and you are putting our data acquisition modules in a field where there may be a lot of EMC interferences, there may be a lot of harmonics, lot of noises, etc. in the field, in the testing field is always there in the testing field. So we have gone with a complete 3-way permanent isolation in all our series of products, that is channel to channel, channel to supply, and channel to bus. So a complete 3-way isolation is provided, and through which we are able to completely nullify your crosstalk between channels, EMC interferences, etc. and you exactly measure what you get from the sensors. So a complete 3-way isolation of 1500 volt DC for EV testing application, because as you know, in an EV, you are going to measure high voltages and high currents. So currents in the range of more than 1000 amps and voltages also in the range of 1000 volts. So you require a system which has got a very high galvanic isolation. So we have gone with the maximum of 1500 volt DC, which will really help you to take all kinds of measurement in the EV testing environment. You might, I am sure most of you might have also used data acquisition systems in the past. So earlier, or the legacy data acquisition systems that you might have seen were really bulky. You have a centralized DAQ system coming. You have to run all the cables from your field sensors to this centralized DAQ. But as the technology is evolving and as the testbed designs are getting adapted to the new requirements, now everybody prefers a distributed DAQ. So as you can see in this slide here, the IO modules are placed inside the test cell and only our controller sits in the control panel. The advantage of having this distributed DAQ is that we are putting the IO modules very near to the sensor, and you don't have to run long cables from the sensor to the DAQ module. So less is the sensor, less is the cable length, less is the data loss. So we take care of all these intricacies when we provide a data acquisition for your testing requirements. And from the controller to the host level software, we have our own software packages, which we will talk about in the coming slide. But we also, since we support multiple communication protocols, our controllers can be handshaked with any third-party devices or APIs available in the market. So now, because of the lack of time, I will not go into detail on various testings of battery, inverter, etc. I will concentrate only on battery testing today. So when you test a battery, what are all the parameters you are going to measure? You are going to measure voltage, current, temperature, vibration, and strain. So we have modules which can measure these parameters at the highest accuracy and a resolution of 24 bits and a sampling of 100 kilohertz, and whatever is the testing standard you follow. So you have different testing standards in different countries. India, as per the AAS standards, our modules can meet these requirements specified in these standards. So what are all the common types of tests that you conduct in a battery? So I have just mentioned some of the commonly conducted tests. There are multiple tests that you conduct on a battery. So it can be like a common test can be a charge and discharge test of the batteries. You can do a safety or abuse testing of the battery. You can do the thermal testing of the battery. You can do a vibration structural stability test on a battery. So all these tests which you conduct on a battery requires high resolution, high speed measurement of data from the sensors, where we can help you out with our data acquisition systems. So let us take the case of a battery. So what are all the typical measurements that you measure on a battery? So the battery, we can divide it into three parts: the cell, module, and the pack. So on the cell level, you are going to do low voltage measurements. So it is in the range of like 3.65 volt to 4.2 volt. Per cell is the voltage measurement that will come. So you don't require a 1500 volt DC isolated module to do that. So for that, we have our 500 volt DC isolated modules, where you can do the measurement of voltage, current, and temperature with the isolation of 500 volts. When it comes to module, the total string voltage will come to around 58.40 volt. So there we have modules which comes with both 500 volt isolation as well as with 1500 volt isolation. So you can directly measure voltages up to a range of 60 volt using our standard A108 modules, and current can also be measured up to 800 milliamps using through current transducers. And when it comes to the complete battery pack, we are talking about a voltage in the range of 800 volt or 1000 volt. And here it is exactly where you require a high isolated data acquisition module. So here we can go with our 1500 volt modules for voltage, current, and temperature measurement. So we also, this slide shows you the importance of thermal runaway in a battery. So as you know, lot of cases, as I told earlier, reported of batteries catching fire. So again, you require a very high sampling data acquisition system with synchronized video capturing to really monitor the thermal runaway when it happens. So the thermal runaway happens very quickly. So it is highly important that you have a high resolution and high sampling data acquisition system to measure that. So this slide shows the complete system layout for a battery testing application. So as you can see here, the complete battery is under test. So we are measuring the cell voltage, we are measuring the thermocouple through temperature through the thermocouples, we are measuring the structural stability through strain gauges or load cells. We are also measuring through videos the real-time position of the battery. And here, as you can see, we can also provide communicate with the battery management systems through a CAN bus or a Modbus. Even our controllers can act as a battery management system. So here you can see the low voltages up to 10 volt or to 60 volt are measured using our A108 modules. The temperatures are measured using our A104 modules, and currents are measured using our 127 modules. The controller, what we provide here is a completely a pack controller or a programmable automation controller. So this controller can be programmed as per your test sequence or as per your testing sequence. We can do closed loop control at a very high sampling. We can even do the battery management capabilities can be brought about into the controller, and the controller can also speak to third-party devices through an EtherCAT network as an EtherCAT slave also. So combination of physical measurements like voltage, thermocouple, strain gauges, combined with live video recording, everything synchronized, time-stamped is what we provide when it comes to battery testing. So some user cases, for example, so we have supplied around 64 battery test cell monitoring systems to General Motors in Detroit. So this is the state-of-the-art battery manufacturing facilities of General Motors. And since we were pretty quick to react to the EV environment, moving from the conventional IC engine testing to the EV testing. So we have, as on date, completed 64 test cells here. They are doing different kinds of tests on a batteries like pack testing, vibration testing, charge discharge test, immersion testing, hardware in the loop testing, etc. with our pack controllers. So General Motors is one of our biggest customers when it comes to battery testing. We also work with Ford in the US. So here again, precise temperature measurement in the range of -40 to 140 degree Fahrenheit in the assembly of the battery condition monitoring applications. So this is again, as you can see in this slide, you can see the picture, the bottom picture, where you can see our data acquisition system connected to a lot of thermocouple measurements. We can also provide solutions when it comes to power calculations as part of your testing. So this is an application which we have done it with ZF. So here we are measuring the kinetic energy which is available to reload the battery of the vehicle. The measurement parameters includes voltage, current, and the power calculations associated with it. So that was on the hardware part, and on coming to the software part, we also have a beautiful software which we call it as the GI bench, where you can, it is completely user friendly, where different GUIs can be created as per your test requirement. You can put various analytical functions over it. So as you can see in this slide, this is basically a slide which we have made for an EV customer. So he is continuously monitoring the voltage and current at 100 kilohertz, and in the controllers we are also doing the measurement of power, that is instantaneous power, apparent power, real power, etc. And we can bring the complete block diagram of your complete test architecture into this. So various dashboards or various GUIs can be created, different data loggers can be created in the software. So as I told you, you can have high-speed measurements at 100 kilohertz. You can have low-speed monitoring measurements also coming at 1 kilohertz or something like that. Everything is time-stamped and everything is real-time. So I will conclude with this slide. So today you may be using our data acquisition system only for a specific local application on your testbed. So tomorrow you will have a number of channels being added to the data acquisition system. You will migrate from one communication protocol to another. You will be using different analytical softwares for validating the data that you get from your testing. You may require connectivity to a cloud or a local cloud or an SQL server in your company. So we support almost all of these. So it can be a local application like IO modules, controller connected to a local PC on a testbed, or from the data which we get it in the GI bench, it can also be put it into various analytical tools like a Python or a Dicey Lab or a MATLAB for your further analysis of the data you come in. We also support cloud connectivity, so it can be our cloud or it can be your private cloud where we can put the data into the cloud through MQTT or OPC or whatever protocol is available. So we always tell our customer, so when you design a data acquisition system for your testing, don't restrict yourself with your current requirement. Also think about your flexibility and scalability, what is going to come in the future. So that is where the capabilities of our DAQ come into picture. So we work with a lot of Indian customers as well as international customers. So some of our premium clients include Tesla, Ford, ZF, the whole of Daimler Group. And we also cooperate with OEMs like Horiba, APV, A&D. And I am happy also to note that the next speaker is IASIS, who is a long-time user of ours here in India for their conventional as well as EV testing applications. So as the famous scientist, Mr. Edward told, without data, you are a person without information. So when it comes to testing and validation, you require information and we help you to get that information, and that information can be turned into customer benefits. That is our duty to help you out with that. And I'll be happy to answer any further questions on this. Thank you.
Thank you, Mr. Rajaram, for this very elaborate, detailed, and wonderful presentation. So I request the participants, if there are any questions to Mr. Rajaram, then you can unmute yourself and introduce yourself and then ask the question. At the same time, I would like to make an announcement over here that this webinar is actually live streaming on YouTube. So please don't record it. You can anyways access this webinar even after finishing this webinar on our YouTube channel. And I have already shared the link with you in the chat box. So, so the floor is open for questions. If there are any questions, then participants can go ahead and ask.
I have one question here. What are all the features which can prevent the battery thermal runaways? Or we are measuring the temperature only and giving the alarm?
So again, you need continuous real-time monitoring of temperature with the best-in-class accuracy. So by doing that, we are able to predict it when the batteries go beyond a permissible limits, and we are able to give you alarm signals at a real high speed, which will really help you to prevent the batteries getting damaged.
There can be an auto cutoff option for prevention from thermal runaway.
Yes, it is all. We can give you analog outputs or digital outputs to your monitoring system or the BMS, which can really cut off that.
Thank you.
Thank you.
So, any more questions are there, or else we will?
Yeah, I can see a question. Can see some questions in the chat which has come.
Okay.
So this is to Akash. So Akash, your question on synchronization of data from different sensors. So we have different. We create different data packets in our controller. So you can define multiple samplings, like some can be at 1 kilohertz, some can be at 10 kilohertz, something can be at really high speed of 100 kilohertz. So we can create different data buffers and synchronize all the data which is coming from your sensors. And to answer Mr. Nitin, so we have our own software which I showed you, which is called as the GI Bench, which can be used to capture the data at real time and analyze the data also. Apart from that, we provide drivers for almost all the well-known softwares which are available in the market. Again, answering to Nitin, the system is completely expandable. So we can start as low as a 4-channel system, and we can go up to thousands of channels in the data acquisition system what we provide. Typically, in an EV environment, the maximum channels what we see is in the range of 80 to 100 channels. Analysis software, as I again told you, can be GIBench, it can be FluxPro, it can be Python, it can be Diadem, Daisy Lab, everything can be possible. You can use different simulation softwares also along with our hardware. I think I will not take much time. I will stick to the timeline. Thank you. Thank you for this opportunity. Thank you.
Yeah, thanks a lot, Mr. Rajaram, actually. And he is going to be there with us for the remaining webinar also. So later on also, if there are any questions, we can ask him, or you can post it on the chat box. He will try to answer those questions that are there. So moving ahead, we move on to our next speaker, and that is Mr. Rutuj Undare. He is R&D engineer at R&D engineer innovation team at ISYS Technologies. So before I actually hand over to Mr. Rutuj, I would like to give a brief introduction to him. Rutuj is associated with ISYS for the last 2.5 years, in which he has extensively worked on the development of EV testing solutions for EV motors. He has extensively worked on the development of EV testing solutions and validation. He has developed test solutions for EV motors, vehicles, transmissions, and e-axles for all segments of vehicles from two-wheelers to commercial vehicles. He has completed his post-graduation from Coventry University, UK in automotive engineering, and has a mechanical background from bachelor's and diploma. Rutuj is working with all the major OEMs to develop test solutions and product validation on all levels. Before I hand over, a brief introduction to ISYS Technologies. So ISYS Technology Solutions is a leading organization for end-to-end product testing and validation. Over 24 years of experience with a global footprint across Germany, UK, Japan, and the USA. With an excellent track record of serving 70+ clients with 550+ successfully implemented systems, ISYS stands at the forefront of innovation with cutting-edge technologies like big data management, e-mobility, ADAS, and autonomous driving, and hydrogen electrolyzer fuel cell testing, fostering systematic problem solving and process-oriented approaches. Committed to purposeful innovation, ISYS empowers engineers worldwide with continuous learning, driving the automotive industry towards digital transformation. He is going to speak upon the common EV testing challenges and limitations that is there. So over to Mr. Rutuj.
Thank you so much, Santosh sir, for your brief introduction of me as well as ISYS. So I'll just wait for you to allow me to share the screen.
Yeah, now you can access the screen actually, yeah.
So is my screen visible?
Yeah, it's visible, yeah. You can go ahead.
Yes, thank you so much, all of the members who have joined in the stream as well as from the live stream on the YouTube. So as Mr. Santosh sir has briefly described the ISYS, I'll just quickly go what ISYS is. So in that, what we'll discuss in the agenda will be a brief introduction of the ISYS. Then we'll discuss the EV trends, what are going on in the last decades and in the future decade, what it will go. And also main topic, which is the common challenges, what we are facing right now, right from the startups and OEMs. So, and at the end, we will briefly talk about how ISS can help you in all these challenges to overcome and make a stable product at the end of the day. So, ISS is 24 years company. So, in the last 2 decades, ISS has briefly worked in the engine testing solutions, where the automation control was the main key area where ISS has worked. So, having the extensive experience of the automotive domain of the last 2 decades, we are currently and extensively working in the EV sector in the last couple of years, where we have helped the startups and the OEMs to develop the testing and validations, test setups, and the test processes to do on their products. So, talking briefly about the products what we offer, right? Majorly, will today focus on the EV segment, where the automation automation control, that is the platform we offer, is the Orbit EV for the electric vehicles. So, majorly we'll talk about the EV applications, but apart from that, I'd like to highlight that apart from EV, we are right now also working on hydrogen engine testing, as well as fuel cell and electrolyzer testing in fuel cell technology. So you can see the research and the development validation going on in the premises, as well as with the major OEMs we do. So with the automation platform, we also do offer the data management software known as Bricks, which helps to analyze the test data as well as the lab data. So we offer almost end-to-end solutions, right from your hardware, software, and after completion of the test, we offer the test analysis and report analysis part as well in the next segment. Speaking about the EV trends, so as we can see in the last decade, how extensively the EV market has been grown. So you can see the numbers just in the last year. It has crossed around 200% purchase of the EV vehicles, which gives and which tells us that how the market is changing from our conventional engine or IC based vehicles to EV based vehicles, and how it will grow from I guess from $210 million market to 94% of the Indian market. So you can see the trend where our Indian market will extensively focus on the electric vehicles, and also coming to that, we'll also see hydrogen fuel cell and hydrogen engine cars, such we can say as a flex fuel or the composite fuel. So speaking about challenges, as we have a very diverse members which have been connected in this webinar, which will be working in the startups as well as in the OEMs. So we'll speak in the both areas where how the startup companies face the challenge in the testing, and how they lack the importance of the testing and validation, and also speaking to the OEMs, how the time, which is a main concern for this OEMs, is there to test their product and launch their vehicle or any product. So first, briefly, we can go through the EV architecture. So you can see the EV battery pack, which has been connected with the module and controller and the inverter, which converts our normal two-phase current to three-phase current. So which has been connected to the traction motor, and this traction motor has been connected to our transmission system or directly to the wheels. Sorry. So this might be a basic vehicle architecture. So it may differ for two-wheelers, three-wheelers, depending upon the size of the vehicle. The specifications of these modules may increase, but the basic architecture will remain same. So connecting to the controller, we have a OBCM, which is onboard charger, and also a DC-DC converter has been connected for the sensors and a low voltage battery. So a major components, if we speak about in this EV architecture, are battery, the motor, the transmission, and the complete vehicle. So the testing of these major components will affect very highly on the product development. So if you're talking about the complete vehicle development, or you're talking about the product development, so which are a product manufacturer such as motors and batteries. So the testing for each and every module or a system or a subsystem will differ according to their specifications. So in the further slides also, I'll briefly tell you about the systems, subsystems, and how the testing shall be done on each levels. So coming back to the challenges, so mainly if you see the startups, so as the EV market has grown, the startups has like extensively grown in the two-wheeler market. If you see, so majorly you see the two-wheeler market has been completely filled up with the startups. So mainly what we have observed in the last couple of years, or what we had the interactions with these startups, that many of these companies, they buy a battery, they buy a motor, they buy an inverter, they just assemble over and they build a bike. But deeply we have to think like, it's not just assembling of the few products and make a vehicle, but the testing of this each product at validation level on the safety purpose, on the functional purpose is very important to sustain in the market as well, and to provide a complete validated product. So I've highlighted a few of the major challenges what startup face. Like first one, you can see lack of infrastructure. So as it takes a huge amount to invest in the infrastructure, so they don't have that facility or a testing facility, you can say, where they can test their products at a very accurate level. Due to that, they lack some of the testing facilities as well as their production. So majorly they go for the production, and then they just roll out the products. So next one, the awareness and the importance of testing and validation. So in this majorly, like what I have been in touch with the startups, I've seen many startups where they had a wide range of models. If you speak about the two-wheelers, so you can see there are scooters, there are bikes, and right now there are super bikes coming with the EVs. But majorly, if you see these startup companies, they just they just assemble these batteries, these controllers, and they have their own vehicle design. They just build the vehicle and they roll out to the purchase. But if we ask them about what type of testing you do on these type of products or your complete vehicle, so they were very unaware, or due to the lack of knowledge of the testing, they were not that much aware. So if we say, like, if you talk about the testing of these products, then a battery can be tested separately. Your controller can be tested separately. Your motor plus inverter can be tested, as well as the powertrain. And combining these whole systems, the vehicle can be tested separately on the chassis stand. So the awareness of these testing should be increased between the startups. The next one will be the unavailability of skilled manpower. As the EV market is very niche market and also a new market, so every day we can see a new development happening in this area. So getting a very skilled manpower is pretty difficult right now, and for startups to get experienced person which have some extensive knowledge in this area is a little bit difficult. So they lack in this skilled manpower area. So next one will be the challenges faced by the OEMs. So what previously also I've mentioned, the time, which is the most important part for the OEM. So how much time they need to give in the validation, and in very less time, the product should be validated properly and accurately, which is the most important thing for the OEMs, because they have to deliver the product as per their standard. So the time and the validation and the testing time is pretty important for them. So next one will be the facilities which are existing used for engines or EVs, vehicle testing. So if you see the OEMs such as Tata, Mahindra, MG, or other OEMs like Ashok Leyland, so they have their extensive the current facility which they are using for their engine testing and vehicle testing. So that will be powered by engine. So how we can use the same facility with some slight modifications for complete their EV testing or majorly if you see the motor testing or the vehicle testing. So that they can decrease the price of the infrastructure which can be involved to completely build a separate facility. So instead of how we can use the existing facility of the engine testing or vehicle testing and convert it to the EV testing with a flight or a slight modifications. Next one will be the right sizing of the equipment. So if you see, there are many equipments were used in the engine testing previously, such as the coolant conditioning devices, fuel conditioning devices, chillers, air chillers, everything. But if you see in the EV, there are very less devices which are being used. So if you are testing a motor, like you'll require a power supply, a DC power supply, which will act as a battery, and a power analyzer, which will give us the electrical data of the testing. So and apart from that, if you have a battery or DC supply, then the current sensors will be important. So we have decreased the devices, but if you see, like majorly it was thought that we are decreasing the devices, or the moving parts in the vehicle are being like they are come down. So it might be easy, but working in this area for a couple of years, we have understood that it is not that it has become easier, but it has become more complex due to the involvement of power electronics into the EV. So dealing with this power electronics will be the main challenge for the EV manufacturers in future. So here also we can say like the right sizing of the equipment. So majorly the devices what we have spoken is the DC power supply or the power analyzer. It takes a pretty huge amount, because these devices are pretty costlier. If you see, if your product is specification is more higher, and then if you go for a power supply or power analyzer, then it will cost you very much instead of that. Like we can select the right equipment according to the specifications of the product. So if you're talking about the vehicle testing, then the selection of the dyno, selection of the roller becomes very critical, where the power and the torque of the dynometer, which will be used for the testing, should be accurately sized according to the specification. But if you go for oversizing and which is not required, then you will spend too much amount instead of going for right size. But as this area is very new in testing, so no one was aware before that. But in this, if you see, the OEMs have gone for the imported systems directly, which can be installed for the testing, where we have seen a very large amount of devices, overpowered devices, which are really not required, where you are testing the vehicle. So if you really doing the product development, such as a controller, or you're developing a motor or a battery, so you're extensively working on that product development, then you require these highly specified products. But within the right size products and right size devices should be selected during the testing. Next one is the test processes. So majorly, there are very few test processes right now are ruled out by the AIs. So if you talk about the battery, AI standards 156 has been ruled out, which is a new one. But if you talk about the motor testing, there's ISO standard which includes the testing which can be done on the motor. But apart from that, the startups as well as OEMs struggles to find the test processes, what types of tests they should be given, and what type of validation should be done, what parameters should be seen during testing when you're testing a motor or when you're testing a transmission. Because as we see in the startups, what I was working with previously, so they were like, when we asked them about like what type of test you want to do on the motor or what type of test you want to do on the transmission, they were completely unaware, because they don't know what parameters should be validated. They just come with the motor and the data what the manufacturer has provided. Apart from that, they don't have any idea. So lack of that knowledge in this area is right now we can see, where working with these startups and also OEMs, we have like we have grown seeing these test processes and doing all the testing regarding to each and every product. So we'll see in the further slide how we can separate it out on the vehicle level, on the transmission, on the motor, and on the battery level. So here you can see some of the standards which can be used for testing. So on the vehicle testing standards and the motor testing standards. So these are some typical standards used for the testing of the vehicles as well as motor. Apart from that, we do have battery standards which needs to be used for battery. So for the vehicle standards, you can see the motor characterization test, WT test, consumption of range test. So this is the major factor where all the companies struggle. So range test, where they have to see how range of the vehicle should be validated, and is the range what they have claimed on the paper, is it really coming on the roadside? So that becomes very difficult for the companies to validate. So for that purpose, we do that range testing that is on the road level, which can be done on the lab level. So that is when we have done in the AS 39 and AS 40. So apart from that, measurement of net power and 30-minute power test according to AS 41. Drive cycle test according to AS 137. So it includes IDC and WMTC. So apart from drive cycle test, sorry, yeah. So apart from the conventional drive cycles test, that is WMTC and IDC, we also test the road load cycles, that are the road data, what we capture from the vehicle. So how that can be tested on the lab level. So that kind of testing we have performed in our own facility. So which helps the customer as well to simulate the road conditions that are very difficult. Like if you see, it is very difficult to drive the vehicle on road for a certain period of time. So if you took one trial, that is possible, but to validate that same cycle, you have to go through multiple trials or multiple repeatability, which is very difficult on the road. So bringing down that level of testing, so that repeatability into the dyno testing or lab testing helps customer or helps the product manufacturers to validate their product. Next one is the acceleration test, which is according to the 40 CFR 1066 gradient simulation test. So in this, we can also see how the vehicle is performing in the various gradient positions. So we can also simulate the human weights on the vehicle with the pinion or with the single drivers, and when the vehicle is fully loaded and still you apply the gradient, how the vehicle performs and how the torque has been developed, what force, what kind of force or what amount of force has been vehicle absorbing due to the dyno. So that also can be done on the lab level. Efficiency test and some R&D test. So it depends upon the customer what he has to test on the vehicle. So moving to the motor standards, there are very few tests that are available as per standards. So measurement of total loss and total efficiency, temperature rise test, where you can see at a certain torque level, the motor is to be run for 30 minutes or more than that to see whether the temperature rises from certain amount and what time it takes. So the ISO 21782 extensively shows us like what type of test you should do and what kind of acceptance should be there during or after the test report is generated. So this ISO test contains all those report format as well. So you can prefer this test for your motor testing product. So if you are a motor development manufacturer, you can perform this type of test. So we are talking completely on the functional test, not on the safety side or on the other. So majorly we are focusing on the performance and the functional testing of the products. So in that we can see the overspeed test, no load induced EMF, and the efficiency mapping as well. So when we talk about the levels of the testing in the this one, so we can differentiate this testing in three types, which is system level testing, where a complete vehicle has been tested. Secondly is the subsystem level, where the motor and the transmission is been there, or a transmission is tested with the other parameters, and then we are coming down to the component level. So we'll go step by step in this. So as you can see in the photo, this is a complete in-housely developed setup in the ISS facility. So where two-wheeler, EV two-wheeler has been tested with the robots as well. So majorly what we have seen is the range test is the key factor for the vehicle manufacturer to show the vehicle range for them. So as I previously mentioned, the repeatability of the road load conditions and bringing down to the lab level is very important for the manufacturer to validate their product. So that we have completely achieved in this setup, where we offer to the customer the road load simulations at lab level. So speaking about the road load simulations, all the drive cycles or all the data what are acquired by the vehicle during the run on the road that are completely being transferred into the lab level. So the force which is observed by the vehicle on the road is been completely given by the or simulated by the dyno on the lab. So here you can see what amount of pressure or forces you see on the road. You can simulate in the lab level. So repetitive trials can be done on the lab. So if you talk about the range test, it lies. So if your vehicle is going 100 kilometers, so the testing might last up to 6 to 7 hours. So in that case, it is very difficult for a human to sit there for a 6 and 7 hours and then test continuous testing, looking to the driver's head and following the path. So there are more chances of the human error where the fatigue of the human might come into the picture. But to overcome this, we have developed a auto throttling robot and auto braking robot. So if you can see in the picture, one robo is throttling and another one is braking. So these are completely integrated with the test cycles, might be a WMTC or might be a IDC. So here, these robots follow the paths of these integrated cycles very accurately, because the main controller what we have in the automation system plays a key role during this, because as we talk about the EV, it is a very high speed applications where your motor itself can go up to 15,000 RPM separately or 20,000. So at that type of speed level, you should have a very accurate controlled automation system where you can control this in 10 milliseconds or 50 milliseconds. So that is been achieved in the lab level. Moving on to the subsystem level, which is a transmission or powertrain testing. So majorly transmission and the powertrain of the vehicle depends upon the size and the type of the vehicle. So if you're talking about the two-wheelers, there might be a belt-driven system or a gearbox, which are right now currently developed by many companies, two-wheeler manufacturers. So you can say a chain drive or a belt drive or a gearbox in a two-wheeler. But if you talk about three-wheelers, four-wheelers and commercial, EXL comes into the picture. So EXL is nothing but you can say a differential attached with the motor, where you just have a single reduction or a double two-stage reduction gearbox in the differential with the motor attached. So in this case, your motor is very high speed, which can go up to 15,000 RPM or 20,000 RPM. And that will give a very high torque up to 70,000 Newton meter at the wheel ends, if you're talking about the commercial vehicles. And it completely differs, rightly said before, on the type of the vehicle. In the transmission, majorly, we do test the efficiency mapping of the transmission with the various speed and torque points. And the controlling of these speed and torque points is during the test is very important, because if you're mapping an efficiency of the transmission, it should be pretty accurate, because it will completely define your product and the range of the product. So next one is the RLS testing. So RLS is nothing but, I've told you, the road load simulation. So road load simulation at transmission level also we have done on the lab level, because every time it is pretty like very difficult for a manufacturer, because if he has 10 models of the vehicle, so to test those 10 vehicles with the 10 separate dynos, then it becomes very difficult for the manufacturer to every time do that. So how you can come down or take down those vehicle level tests to the transmission or motor or the component level, onto the component level, that's what we have been working on. So in the RLS testing is also possible on the transmission, which gives complete system efficiency right from your battery to wheel in the single setup. So if your transmission is connected with the dyno, then your DC supply will be acting as a battery. So you can say, like, right from your battery to your wheel, you can get a complete transmission efficiency. So the test cycle that can be performed are drivetrain efficiency mapping, motor efficiency separately. You can take RLS Tesla, what I have told, the complete system efficiency mapping. And also apart from that, the durability test can be done in the same setup. So you don't have to go for a separate durability setup apart from the efficiency. So this durability test can last up to 500 hours or 10,000 hours, depending upon the manufacturer's limitations. So this is a layout of the EXL testing lab, what we have worked. So you can see the layout where the two dynos are connected to EXL, which is connected with the motors. So here you can see a complete lab setup we have made along with the battery. So two drives will be controlling the two dynos during the EXL testing with with the main drive and also the battery and the controller. So if you see, there is a lot of power electronics involved in this complete setup, and controlling that, our ISS software is pretty much capable, and we can control the drives, the DC supplies, and the batteries very accurately. So these are some photos of the transmission testing what we have performed for the customer. So if you can see, this is a belt-driven transmission of a two-wheeler, where at the first picture we have connected a dyno to the wheel end, where you can take the complete powertrain efficiency, and in the second picture we have connected the dyno to the primary end. So we have kept that kind of feasibility and that kind of feasibility into the system, where you can have a step-by-step efficiency as well. So here we have worked with a couple of two-wheeler manufacturers to provide this type of solutions. So talking about the integration with the vehicle controls, it is a very important part, or it plays a very important role into the system, because the automation system needs to be communicated with your vehicle, with your component, or with your product. So the communication or the integration between these controls and the automation system is very important. So in the EV, what we can say is the MCU. If you're testing a motor, so motor controller is the main unit where you communicate with the motor through CAN. And if you're testing a vehicle, you communicate with the VCU to monitor the vehicle data. And if you're testing a battery, so the BMS needs to be communicated with the automation system to monitor the other parameters as well. So you can see during the testing, apart from the dyno data or the lab data, how the vehicle has been performing, what are the vehicle data you can monitor during that testing. So integration of the vehicle controls plays a very key role, where we have extensively worked from last 2 decades. So coming to the component level testing, which is a motor testing. So in this, we have faced a lot of inquiries, or you can say we have dealt with our customers right from two-wheelers manufacturer, three-wheeler manufacturer. So where they were unaware of the testing, what needs to be done, what parameters to be validated, how we can validate our vehicle data into the motor. So we have came around very different cases. So one of the customer we have been worked on was a EV dirt bike manufacturer. So that was completely a new area where we have worked, and we have tested the EV dirt bike motor into our facility. So you can see the dirt bike application is have a very transient behavior. So testing that kind of transient motor is pretty challenging because your system should be that much capable to control that testing in very few milliseconds of time. So majorly what we do on the motor testing is the performance testing, the durability testing, and also RLS testing. So the graph what you are seeing in the picture is the same road load simulation graph. So this was the dirt bike RLS test what we have performed. So at the bottom end, you can see it was just a 60-second cycle where your speed was going to 3,500 within seconds and was dropping up to 0. So that kind of transient behavior we have been testing at our lab, which requires a very precise controls of the automation. And in the RLS, what we have discussed as well, the WMTC and the IDC, that road duty cycles can be tested on the motor as well with the help of vehicle parameters such as drag force, roll force, and other parameters as a weight. So combining that parameters, how we can take the vehicle data and do the road testing onto your component testing, which will pretty help to all the manufacturers ahead. So this is a simple architecture of a motor testing where you can see a DC supply or a battery has been connected to the controller, and then the controller is communicating with their vehicle motor, and the dyno is been attached to the motor. Here the dyno has been dynamometer has been communicated with the drive. So all this system are monitored from a single automation system. So this is a simple architecture with the DAQ. So in the previous lecture, we have heard from the Raj sir about the DAQs. So these are been used during this testing. So in the use cases also, apart from the dirt bike, there was a case came from the EV manufacturer OEM two-wheeler, where he wanted to simulate a road speed bump case into the powertrain level or motor level testing. So for your reference, I've just attached a graph you can see over here. So on the x-axis, we can see the seconds, and on the y-axis is the RPM. So you can see within milliseconds how the RPM and it has been changing from 2000 to 4000 within milliseconds. So creating that environment or creating this type of testing into the powertrain becomes a very challenge. But with the accurate controls from the controller, from the automation, we have done this type of testing on our test bench in the lab level. Coming to the battery testing, so majorly the powerhouse, we can say, of the vehicle is a battery. So the testing of this battery is very important. So might be on the functional level, might be on the physical level, or from the safety point of view. So I've mentioned some of the standards which can be used for the battery testing. So the main aim of the testing or the standards is like how you can come down, or how you can come down from the vehicle testing to the battery, or you can say the range testing, what you do on the vehicle, how can we done it, or how can we do it on the battery with the help of simulation will play a major role in future, because it will save a lot of cost and infrastructure for all the OEMs and all the product manufacturers. Yes, as we spoke about the RLS at motor, we can similarly do the road load simulation cycles on the battery level as well, where you can test your road cycles such as WMTC and IDC with the help of a DC supply, which will be acting as a source and sink and be connected to a battery, and it will pass the current, or it will discharge the battery according to the model which has been deployed. So on that part, we are we have done some research on that as well. And majorly on the battery testing, the range is the main parameter what we test on. So the battery SOC, the state of charge is the main thing what we see. So bringing it into the simulation level using a MATLAB will play a very key role in future. So it will reduce too much cost which will be involved during the testing. So with the help of MATLAB, as we work with the MATLAB as a partner, so with the help of a MATLAB and our own data management software called Bricks, we have done some battery SOC predictions onto the simulation level, where you won't require a physical test setup as well. So that's the main aim what we will be looking in future to coming down from a road level testing to a lab level or into the simulation level testing. So that's what we have talked about the testing. But to support to this testing, the digital transformation, what you have mentioned, is a very important, because right from designing the test and testing, and then after you test some product or a vehicle, you generate the test, and then you generate the test reports. So to analyze that test report, you should have some applications, because I've also heard a few questions regarding this. So the post analysis part, because in the first session also, sir has mentioned that a lot of data will be generated, and which will be in the terabytes. So to analyze those data, which will be very critical for the future to develop the products, and to reverse engineer what has gone wrong during testing, or how we can improve using this data, becomes very crucial. So for this, we have one specific flow using both our automation platform as well as a test data management platform named as Bricks. So in that, where right from designing the test or the DVP till the post analysis part, how we can help you in this process. We can see, like after we do the DVP, then the approval flow is been go to the what test you're doing, and the test methods, the test has been scheduled, then resource has been allocated. So once the resource is allocated in orbit EV, you can perform the test, you can execute. So once the test is executed, you generate the test data and the test report. So this test report is then again analyzed into the Bricks platform, and we can store and analyze this part. So digital transformation will play a very key role into the EV testing and validation, as a very huge amount of data will be required and will also be generated during the testing. To summarize the complete session, that majorly what we have seen is the functional testing of the various products, might be at the vehicle level, might be at the motor, battery, or a transmission, where drive scenarios we have considered. Majorly, we have seen how a range can be tested on the vehicle level as well as motor or the battery level. The drive cycle simulations, the network test, functional test, performance analysis, and load test. So how ISS can help? So as discussed, so we have separated, or we have made a pyramid where from starting from your element level, that is cell level, module, or battery pack level. Then we go to the component level, where motor controller with BMS or battery, a subsystem level where motor with the powertrain or motor with the battery. In the next level, powertrain validation, where the transmission has been tested, and then we'll go to the vehicle validation, that is on the lab level, where your complete vehicle will be tested in the lab. And then at the top of the pyramid, you can see the on-road validations. But the main aim will be to bring on-road validations, the top pyramid, to the base structure, that is the element level. So how we can transfer the on-road validation into your component level testing, that is to the battery, will be a main role. So we are working since last 2.5 years on this part of area extensively with major almost 40 to 50 customers we have worked, or we have been in discussion and in contact with. So we have gone with many challenges and real life scenarios, which have helped us to analyze and to sum up this all the testing and validation data into one pyramid. So which will help you as well to validate and to develop the product. That's all from my side. Thank you so much for everyone to patiently hearing, and we can start with the questions if there are any.
Okay, thank you, Rutuj, for this elaborate and actually very detailed presentation. I guess there is a lot of one of our speaker is waiting, so I guess what we can do is that we will have one presentation, and in the chat box the questions are there. We can discuss the questions slightly like after 5 or 10 minutes of the presentation.
Definitely, sir, definitely.
So I guess that's not an issue. I request all the participants that they should hold for Rutuj questions. We will have this question answers after these two presentations that are there. So he is going to be available with us. And in the meantime, you can answer the queries that are in the chat box, Rutuj, if you don't mind.
Sure.
Yeah. Okay. Fine.
Yeah. Thank you so much. Sir.
Thank you very much.
Yeah. Thanks to give this opportunity for us.
Okay, so that was Rutuj for this presentation. So next we have Mr. Mitchell Marks. He is Business Development Electrification from HBK. Before I hand over the rights to him, just a brief profile about him. Mitch has worked in electric motor development since 2015 and specializes in the test and measurement of traction motors and drives. He focuses on developing new testing techniques and accelerating the development process. He has been with HBK since 2017 as a member of the electric power testing team. He has an undergraduate and a master's degree in electric engineering from the University of Wisconsin, Madison WEMPEC program. Over to you, Mr. Mitchell.
Thank you, and I hope you can hear me all right. And I think you need to enable my screen share.
Yeah, just give me 1 minute.
Yeah, no problem. While I wait for him to get the screen share enabled, for those of you who don't know, HBK is a large testing company. We are focused on test and measurement of physical phenomena. So that ranges from structural testing, sound and vibration, simulation, and then of course electric power. So HBK makes sensors, data acquisition systems like we'll discuss today. Many of you might know us for our torque sensors, and then analysis software, as well as we do have vehicle simulators. And I must say, Mr. Undale, I appreciated the presentation. I think we should talk afterwards after you see our presentation. So with that, with the quick HBK overview, I will jump into it because I think we're a little behind schedule. But this presentation is power measurement done quickly and safely without EMC issues. So we have some really exciting developments in the world of electrical measurement. Quick agenda, we'll start with the electric powertrain and power measurements, just a brief overview. We'll look at a typical approach of power measurements, so voltage and current measurement with conventional power analyzers, issues with wiring, increased voltages and frequencies. We'll then come to a new approach, which is actually a new product we're launching. How we simplify cabling, how we simplify EMC issues, how we highlight safety, and how we increase the speed of test. And then we'll come to a summary and conclusion. So thank you all for joining. And we'll start with the electric powertrain. Very, very similar to what Mr. Undale showed and the gentleman from Gantner. Electric powertrain testing, we have a power source, we have an inverter, we have an electric machine, and we're making a significant amount of measurements. We're measuring DC voltage and current. We're measuring high frequency AC voltage and current, and this is at the the 10s or 20s of kilohertz rate coming from that inverter. We're measuring torque and speed. We're also measuring mechanical things. We're measuring the temperature of the motor. We're measuring the temperature of the battery and inverter. We're also interested in acoustics and vibration coming from the machine. This is an extremely electromechanical system. What happens in the inverter affects the experience, it affects the noise. There's also that vehicle level CAN bus we need to log. And we need to communicate with an automation system. So we need CAN or EtherCAT going from the measurement unit to an automation system. And then we need data visualization. And what we find is even with the system from HBK, where we can make all of these electric and mechanical and digital measurements in one place, there's a lot of cables. There's a significant amount of cabling. There's high voltages. If you have more instruments, you have more PCs, this becomes even more complicated. So as a baseline, we have lots of measurements at various frequencies with lots of cabling. So what's a typical approach? So the best case scenario we have for cabling, the best case today is we have, again, our battery or our power source, our inverter, our motor, our e-axle or gearbox. We have 4 minimum current measurements. These are usually going to some sort of CT power supply. So we have 4 cables here at a length, and then we have 4 cables coming back to the power analyzer. Now, if you add in a scope or a data recorder or some other things, you start adding more and more cabling. It's a complex issue. So we have 8 cables minimum just for current. We are seeing in hybrids or in some of the German auto manufacturers, them going to higher phase counts or more complex systems. That's just adding cabling and complexity. Then we have the voltage measurements. And again, we have minimum 4 voltage measurements, and these are usually going a long distance, carrying high voltage. And here we'll see in a moment, this poses a safety issue. Then, of course, we have our cables carrying torque and speed. Again, these are all copper cables, and we have a minimum of, 4, 8, 12, 13, 14 cables coming from our device under test, coming from our high voltage systems to a measurement unit. This is best case scenario. If we have more instruments, we have more cabling. If we have higher phase counts, we have more cabling. So just kind of prepping you up for what the best case scenario is today. Oh, and I hope I didn't skip too far. What does this look like in reality? Now, I know none of your labs have ever looked like this, but this is a picture from a customer of mine where we have, an inverter down here being connected to a power analyzer. I think this was a 6-phase system. So we have tons of cabling. We have torque and speed. We have coils of wire. We have things stacked on one another. This is a nightmare. I mean, we have the thermocouple measurements, controllers just hanging out. This is a safety issue. This is an EMC issue. This is quite terrifying. And even if we look at like a good current cabling, I mean, we still have lots of area for noise. We have bus bars quite close together. We have cables overlapping. We have various things coming through. So this is the reality, and this can become quite messy. And I mean, messy means safety issues, messy means bad measurements, and messy means mistakes are made. So these are the things we're going to want to avoid. So let's look at problems with the typical cabling. So this is what I showed previously with our 14 cables. High voltage safety. We're seeing these DC buses go ever higher and higher and higher. I mean, I think in commercial automotive, there are some DC buses that are at the 900 volt level currently. I mean, that is serious safety. Even at 100 or 200 volts, what we might see in a two-wheeler, that is a safety issue. So we have this high voltage from the inverter all the way to the power analyzer. These cables are high voltage the whole way. And we want that right now because that is how we retain our accuracy. Voltage probes are inaccuracy. We don't want that. And then if there's a copper connection to the automation system or a copper connection to your host PC, now we have a safety issue that involves humans. So we have both the safety of the instrument and the safety if you are connecting it to a PC for safety issues, which not all instruments are that CAT level. We also have EMC issues. These current cables have a length. This length has a capacitance. Capacitors conduct EMC. We also have another length of cables because we have multiple cables. Again, these cables are low voltage. They're susceptible to picking up noise. And these inverters are just EMC machines. We have these inverters with their rise times. These rise times are going to create a large amount of EMC that can get coupled to measurements. And we'll speak about that, the math behind it in a minute. But basically, all of these current cables become an antenna. These voltage or these torque and speed cables become an antenna for coupling noise from these inverters that are turning these voltages on and off extremely quickly.
I guess there is some network issue that is we are facing. Actually, we will hold for 1 or 2 minutes and just see if Michelle joins back actually. Yeah, he's back actually.
I'm sorry about that. I just got booted off.
Yeah, that's fine. You can continue, Mr. Mark.
Sounds
Yeah.
great. Yeah, could you enable me to share again? I apologize, everyone.
Yeah. Just give me 1 minute. Yeah. Yeah.
Perfect. All right. Again, I apologize, but yeah, hopefully that woke everyone up who fell asleep on me. So again, we have this safety issue. We have these antennas everywhere, and then we get into areas like ground loops being created, where you might have instruments stacked on top of each other. So there's a lot of issues, and even small things make a big difference in these inverter-driven systems. So what are the new challenges? What are the industry trends? And I'm sure everyone here has heard about wide band gap switches or silicon carbide or gallium nitride coming into their inverters. Why are these things issues for measurement? There's plenty of challenges involved with them. Otherwise, I'm not going to get into that. But why are these things challenges for measurement? Well, there's this little equation that is the equation for current in a capacitive system from base physics, and it is current equals capacitance times the change in voltage over the change in time. So let's look at a couple of industry trends and how those are affecting measurement. So we have an increase in battery voltages. I think this is just a generally accepted trend. Well, if that voltage is increasing, when I turn an inverter switch on, my change in voltage is increasing because the battery voltage is increasing. So you have an increased dV. So this increase in dV alone, every measurement line that has a capacitance has an increased little bit of coupled current to it, plus high voltage safety, plus higher measurement ranges needed for accuracy in the measurements. Oh, sorry. Next, we go to silicon carbide and gallium nitride switches, which are turning on very fast. The turn on times for these is in the tens of nanoseconds. Well, this is lowering my DT. So I have an increase in my voltage, I have a raise in dV, I have a decrease in the switch time, my DT lowers, and these cables are going to create a capacitance. So any cable I have, any capacitance I have, is going to make the current increase. So we can see that dV up, DT down, that current induced on our measurement cable for any capacitance is going to increase that coupled noise. You add longer cables, you add loops, you're just making this worse. You're increasing that capacitance. So new powertrain demands are difficult to measure. So what is HBK doing to solve that? Now this is kind of the new product release. Again, just as a review, we have this setup where we have these long voltage cables, we have these long current cables, we have torque and speed cables, all coming back to a best case scenario, a common measurement unit. But we have high voltage safety, we have EMC issues, we have all of this stuff. What HBK is going to propose, and this is a product that will be available later this year, early next year, depending on some of our release timing, is a fiber optic probe-based system. So the beauty of this is we don't give up accuracy while having this probe because we have this little box. And this little box sits right next to your measurement. You could have a 10 centimeter measurement cable. These measurements come in, we digitize them, we do all of the amplification locally on this box, and then we send it back over a fiber optic link to the measurement unit. Same with currents. We have a built-in power supply where we're measuring our current sensors. We could have a 10 centimeter cable. Now, shorter cables, lower capacitance, less room for there even to be noise coupled, less proximity to those high voltages. So this is going to be really great for reducing that EMC. We digitize it. We do all of the amplification, all of the fancy measurement stuff, fiber optically link it back to the power analyzer, to the measurement unit. Torque and speed today are still going to be copper. That will be coming as fiber optic in the future. So what does this do? What does giving us these fiber optic boxes right next to the measurement do? Well, it gives us uncompromised safety. A fiber optic link has no copper connection. This means there's no high voltages coming back to your control room, coming back to your instrument, interacting with other cables. So this is really as safe as it can get. This eliminates EMC issues, short cables, lower capacitance, less proximity to other high voltages, less proximity to EMC. This is really going to cut down your noise, cut down your headaches, cut down your troubleshooting. Higher accuracy due to shorter cables. I've mentioned this 12 times already. But as we shorten those cables, we lower that capacitance. And with these high slew rate switches, we get into the kind of base physics issues of reflections. Integrated CT power supply is just going to cut down the number of cables you have. Again, lower capacitance, lower cable count, lower ability for noise. And we can distribute these up to 50 meters apart. I think this is really cool because if you have a setup where you need to have measurements not necessarily right next to each other, I think, for example, a current sensor cabinet, or for example, those of you who might be working on aircraft, if you have distributed systems, or if you're working on large trucks and you have multiple measurements across the vehicle. Again, you don't have all these cables coming back to a common measurement. You don't have all these antennas. It really simplifies your setup. It makes it more safe and it raises the quality of measurement. So what does that look like in my little animated diagram? Well, we have our power analyzer with fiber optic links going to our probes. Eventually we will support torque and speed as well. Initially, it'll just be voltage and current. We automatically cut out long cable lengths. We reduce the number of cables so that we lower the amount of EMC. It's still there. It's still there because the inverter is still there. But we significantly reduce that EMC risk and we completely decouple the instrument and the users from the high voltages. So it's extremely safe. What do these look like in reality? So they're these little boxes. They're maybe 20 centimeters by 10 centimeters, maybe 30 centimeters by 10 centimeters. They'll offer 5 voltage ranges up to 2 kV. So we're going to that higher voltage. They'll be available in 2 megasample or 20 megasample sample rates. So you can measure that really high, really high rates. So you can get that highest quality measurement. And you can use these as a scope for many of your motor control needs. So again, we're replacing multiple instruments with one. Again, further simplifying your cabling, simplifying your software, simplifying your safety and your EMC hazards. So that's the voltage box. The current box will have 6 ranges. We have all those ranges for accuracy. We support really the highest accuracy in industry. A lot of details, but also 2 or 20 megasample, optional built-in power supply. And then we have a fiber optic receiver card, which can make all of these measurements fairly economically. Just further details, highest CAT ratings on the high voltage module. So this will have the highest safety. The 2 megasample version will have a 2 megahertz bandwidth. The 20 megahertz megasample per second will have a bandwidth closer to 10 megahertz. All the filters that you could ever want. And again, we have that really, really wonderful power accuracy. And if you think about this power accuracy without that noise, it becomes extremely simple. It becomes very reliable. So extremely excited about this. Much the same with the current box. Again, super high accuracy, high sample rates, high bandwidth. These things are going to be fantastic. Simplifying that cabling. So the vision is eventually we will have everything over fiber optic. Voltage, current, torque, speed, temperatures, NVH, all coming in fiber optically. fiber optic connection to the automation system. This is over CAN or EtherCAT, fiber optic connection to your PC, and then everything is completely isolated. We have the highest measurement quality and the highest safety levels. And then today we have our perception software, which has some really sweet analysis tools for doing efficiency mapping, for looking at things like space vectors, DQ0, drive cycle analysis, and energy consumption is a big business for us. So for your range testing, for your certification, like the gentleman earlier was speaking about, we can certainly help with that. Noise and vibration is another area we're getting into for that analysis, but it all starts with the high quality, high reliability, high safety measurements. So summary and conclusion. For those of you who are not familiar with the HBK power analyzer of today, the optical power analyzer is quite simple. And please reach out to me if you have any questions, but we can go up to extremely high channel counts, hundreds of channels if needed. We can do electric and mechanical measurements. So we can bring in your torques, your speeds, your voltages, your currents, your temperatures, your accelerometers, all in one place to, again, simplify that software, simplify that measurement. We offer real-time bus in and out. So that's CAN bus, EtherCAT for integration into an automation system. We offer high voltages natively, but we do have 5 kilovolt dividers if you really need to go to high voltage. Built-in CTs and very high sample rates. We actually have a 250 megasample card that is not high voltage if you need it. We can distribute our mainframes up to 500 meters. We can store data at up to 400 megabits per second. We can store a ton of data. We're not like a scope. We can store data for minutes, hours, for things like your range testing. We have some really cool tools. And then if we add the remote probes to our existing system, we end up with that extremely high safety, a huge amount of flexibility, being able to move the modules around up to 50 meters apart and mix as many voltages and currents as you need. For example, if you were doing a range test, you only need a couple of DC channels, but you need a lot of current channels. We can easily measure that. Higher accuracy, less EMC means higher accuracy. Better results, shorter cables, simpler cabling, make your technicians' lives easier. And then lower operational cost. You're gonna spend less time troubleshooting. You're gonna have higher quality results. You're going to have fewer headaches. So with that, if any of you want to reach out to me, please send me an email. You can also reach us on the chat. And if you want to learn more about HBK, please scan this with your phone and that will take you to our webpage. And from here, I'd like to thank everyone and I look forward to questions.
Thank you, Mitchell, for this wonderful presentation. And thanks a lot for making yourself available from outside of India. He's joining us actually. So thanks a lot. So if there are any questions, you can ask Mitchell any questions that are there. Participants can unmute themselves and go ahead and ask any questions to Mitchell. Okay, that's fine. Mitchell,
Yes,
go ahead. Yeah.
What is the difference in torque flange using in currently in dynamometer, diesel dynamometer? And what is you are using here in electric dynamometer? What is the difference both type torque flange?
The different torque flanges? Yeah, so HBK offers a variety of torque flanges. So we're formerly known as HPM, which you might be familiar with. It really comes down to what your torque level and what your accuracy requirements are. So we have the T12 HV, which is just this super accurate sensor with a really nice 6 kilohertz bandwidth for making things like calibration measurements where you need to compare two things. So I like to tell people that T12 is really for making comparisons because it's so accurate. Or if you need to measure a really small range with a really or a really small measurement with a really wide range, T12 is you can't beat it. T40B is a little lower accuracy, still extremely good sensor. This is more, you just need reliability. You need a highly accurate measurement. You need repeatability. And then for low torques, we do have flange type sensors, which come at a lower accuracy, a lower reliability. But for really low torques, those are hard to do with a telemetry based sensor. So we have those three types. We have kind of the low torques, the flange based, or the pedestal based. We have the T40, which is kind of you just need a really good measurement, really accurate measurement. And then the T12, which is you need to make very fine detail comparisons. And those all do plug into our power analyzer. So you can be time aligned with the really accurate electrical power measurements as well, because that timing does matter.
Okay, thank you.
Thank you for the question.
Okay. Thanks a lot, Michelle, for coming on this webinar, and thanks a lot for answering this question. He has already mentioned his email ID, so any questions are there, you can definitely write a mail to him. He will definitely get back to you. So thanks a lot. Thank you very much.
Thank you.
So here we come to the final presentation that is there, and it is going to be from Mr. Ankur Panchal. He is a manager, homologation and regulations at Hope Electric Mobility Private Limited. So before I hand over to him, a brief introduction about Ankur. Ankur is an automotive professional with 14 years of rich experience in the field of homologation and certification of vehicles, working with EV industries in the last 2.5 years. He has worked with companies like Suzuki Motorcycle, India, Yamaha, VCA, Certification Agency UK, and Ola Electric, to name a few. Currently, he is working with Hope Electric Mobility Private Limited as a lead of homologation and regulations department, and supports the organization in getting approvals from certification authorities like ICAT and ARAI. He is going to give a presentation on EV certification requirements. Over to you, Ankur. Yeah, Mr. Ankur, are you there?
Hello, just give me a minute.
Yeah, okay, that's fine, that's fine. Okay, I'm making you a co-host, so you can just take it over from there.
Hello. Hello, am I audible?
Yeah, you are audible, Ankur. You can go ahead. Yeah.
Okay, thanks a lot. First of all, thanks a lot to the my directors. First of all, to allow me to join this platform, and thanks to you for organizing such a event. So today I'm going to discuss about the homologation requirements specifically for EV. In general, see, there are such requirements which are set to qualify a vehicle to go through the whole homologation procedure, which is similar to the IC engine as well as the EV. So during my presentation, I will talk about the homologation mechanism here in India, EV homologation background, and the CMVR approval requirements. Post that, I will summarize my presentation. I will not take much time. So to begin with this, what is homologation? Homologation is to get a vehicle certified or to check the roadworthiness of a vehicle, whether it is a car or motorcycle or an EV. So basically the procedure, the testing and the certifying a vehicle by following some rules and regulations set by the government. So here in India, we have some requirements set by the government of India. So if you see the slide, so the government of India, there are ministries below that. So MORT, Ministry of Road Transport and Highways, which governs everything, which is responsible for rule making and all. So post that the other ministries are there, Ministry of Heavy Industry, Ministry of Environment and Forest, Ministry of Consumer Affairs, PCFT and other ministries. So they have appointed committees like ARI is the secretariat for making or rule making procedures here in India. If you talk about the CMVR rules, so CMVR rule, there is a procedure to become a CMVR rule. Before the early stage is the AIS, the Automotive Indian Standards. The Automotive Indian Standards formed based on the requirements from the industry. So there is a body for Society of Automotive Manufacturers, which is planning or organizing meetings by gathering all the fraternity together. People from the automotive fraternity join this and support in the rule making. So these AIS are formed. Post that AIS are formed, the AIS goes to the AIS, which we call it Automotive Standard Committee. This Automotive Standard Committee is chaired by the director of ARI. Being ARI is the secretariat, the director of ARI is chairing and guiding how to proceed further with the rules and regulations being set. So once it is approved, all the rules or the standard being approved by the AISC committee, it is being forwarded to the CMA-TSC, that is Certain Motor Vehicle Rules Technical Standing Committee, which is led by the Joint Secretary MORTH, which is one of the ministers appointed by the government. So once the rule or the standard being approved in the CMA-TSC, it becomes a rule and it is getting certified in the form of a GSR or SO. And post that standard, once it comes in the practice, it becomes Indian standard. So this is how all the rule formation here in India works. Now we come to the EV regulation background. Things were way back, if you talk about way back in 2013, the work was there to form the technical regulations for battery operated vehicles. And finally, in 2005, the mandatory requirements came into force. If you see this picture, it can show you the number of vehicle categories. Some of are there. You can see the battery operated vehicle less than 50 watt, they are exempted, and you need to take the approval. There is no type of requirements as such. But for L1, L2 category and 5M category, there are some set regulations for CMA certification perspective. So there is a very, a lot of improvement has been done by comparing with the European standards, by deep study and the case scenarios has happened in the past. So based on those events, the basic things have been improved. Let's come to this battery approval process. So I want to show you one more thing to explain about this homologation procedure. Here I will take this ready reckoner provided by ICAT. So if you can see, there are number of tests are there to be performed to get a CMA certification, not only range energy power consumption test. So in case of EV, these are the three tests which are being catered maximum. Focus is on the electrical energy consumption, the range, measuring the range and the power. So these three tests are the major tests in case of EV. Apart from them, if you see, lot of the tests are common with the IC engine testing, which says about the performance of the vehicle, which says about the safety of the vehicle. If you see or go by one, the speedometer calibration, the noise which comes under the environmental testing, the telltale symbols, the gradient performance, the wind verification, the horn installation, and the AHO being implemented 2017. This is one of the requirements which one has to follow here in India. The IVR, RVM installation of lighting and signal devices. So all the manufacturers, those are applying for CMV certification, they should have their components approved as per CMV rules. Apart from these, there are some testings like footrest, stance requirement, external projections requirement, which are newly added. These new requirements are newly added to CMV certification in case of two-wheeler. EMC was got implemented in 2013 initially. Now it is applicable for both the IC engine and EV. And construction and functional safety, this is most critical thing in case of vehicle approval. So there should be no direct current. There should be no shock to the user or the passerby. So this standard says about this. Now if you see, there are the safety critical component which has to be approved as per the CMVR. The horn has to be approved. The rear windows are also approved. The tires should be approved. And all the lighting, whether it is a headlamp, tail lamp, direction indicator, those are the lightings are there. They should be approved as per the standard, including the brake hose, brake fluids, and wheel rings. So there is a new requirement in case of wheel rings also here in India. So every manufacturer has to take the BIS compliance, and the date would be December 2023. And one more implication is there now. The traction battery, now they are testing it as per AS156, and the AS156 is divided into two phases. The first phase came into force in December 2022, and the phase 2 implemented in March 2023. So these are the critical parameters which has to be followed to take the traction battery type approval. So every manufacturer now have to apply for the type approval and go through the stringent testing of batteries to make the vehicle safe on road. Now come to the presentation. So these are the battery approval testing, like vibration test, thermal shock test, mechanical drop test in case of removable battery, mechanical shock, fire resistance, external short circuit protection, all charge protection, all discharge protection, all charge protection, thermal propagation. And thermal propagation is one of the most critical tests which is been recently added in the standard, just because of the past bad events happened. The vehicles have catch the fire and some mishappenings has happened. So the government has been very strict nowadays. They have implemented these new regulations for battery approval. So they want to keep each and every vehicle safe on the road. They want to keep the passerbys and the riders safe condition. That's why thermal propagation is being added. So thermal propagation is there in case of any thermal runaway condition, case due to some external or internal case the thermal runaway cell, the cell which is being on in the thermal runaway condition, it should not propagate to the other cells so that the fire condition should not be there. And one more condition is there in thermal propagation test. Before the thermal runaway happens, the temperature of the cell should be not more than 60 degrees Celsius. So once it is reached 60 degrees Celsius, so it will give an audio visual alarm before 5 minutes to the rider, and it should be displayed on the vehicle and the battery itself. The battery should give alarm and the display should be presented to the rider so that the driver or the rider will get enough time to safeguard themselves. And this is how this thermal propagation test can save the people around. And let's come to the vehicle testing. The vehicle testing, general testing, as I have already told you, the major test, if we are talk about the in case of EV, the energy consumption and the range measuring of range and the motor power test. So these are the three tests which are being done in case of BOVs. However, other tests, as I already presented you, they are similar to the IC engine vehicles. So this is from my side. If you have any questions, you can ask. Thank you.
Thank you, Ankur, for this very small, sweet, and very crisp presentation that was there. So I guess if there are any questions, participants can unmute themselves and they can ask Ankur the questions. He is there for us to answer those questions. Any questions from participants to Ankur? Okay, that's fine, Ankur. Thanks a lot for coming on this webinar and sharing your insights on the EV certification requirements that are there. Thanks a lot.
Thank you. Thank you so much.
Yeah. So actually, we had Rutuj also. So there were a few questions from the participants. So Rutuj, if you are there online, if there is any questions from any participants, then they can ask Rutuj also, because there was some time management that had to be done. So that's why we did not take the questions to Rutuj after his presentation. So Rutuj, are you there?
Yes, sir. I'm there.
Yeah. Okay, fine. So participants, he is there available. So if there are any questions that are there, you can ask him actually. Okay, that's fine. I guess there were a few questions in the chat box that you have already replied to those questions
Yes.
that are there. Yeah, so thanks a lot. So with this, actually, we come to the end of this session, wonderful session that was there, where we discussed on the different requirements of electric vehicle testing, validation and certification, the challenges, and few of the technical developments that are happening in this sector. So before we end, actually, I would like to thank all our participants, speakers, and sponsors for joining this webinar. We like to especially thank our sponsor, that is ISS Technologies Private Limited and Gander Instruments, without whom this webinar would have not been possible. So thanks a lot for coming on board. I would like to also thank our supporting associations, the Indian Electric Mobility Congress and the India Energy Storage Alliance for supporting this webinar. Even Electric Mobility Finances Association of India and Smart Energy Council Australia for extending their kind support for this webinar. So with this, I thank all the speakers and all the sponsors and participants and associations for making this webinar a huge success. Thanks a lot. Thank you very much. We will keep you updated with our next webinar that will be coming up in next month. So you can, as I said, this webinar is already available live. We were streaming this live on YouTube. So anytime you want to have a view again, view this entire webinar that is available with there. I have already shared the link on the chat box. You can subscribe to the YouTube channel. You can also subscribe to the Smart Energy LinkedIn page so that you can get all the details and updates from the electric vehicle, solar, and the green hydrogen energy industry. Thanks a lot. Thank you very much.
Thank you.
Thank you, sir.
Thank you all. Have a good evening. Bye-bye.
Thank you.
Thank you, sir.